Okay, so welcome to chapter 2. This is the next segment of the class, and then chapter 3 will be next week. And chapter 3, just as a heads up, I tried to do a little practice run on chapter 3, and it's a lot in a short period of time. So I'm probably going to just cover half of chapter 3 and maybe half of chapter 4, and then I'll go back and do the other half of 3 and the other half of 4 or something like that, so I don't overwhelm you. Because for those who are not haven't had an electrical engineering class or don't know about electrical components or things like volts, watts, amps, it might be a little overwhelming at first. So I'm going to just give you half at a time. It'll be a little more digestible for you. So, all right. So, chapter 2, radio signals and waves. Okay. So I had a physics class in college, and I think it was physics, I don't know if it was 121 or 122 at BYU, but we did wave theory, and I learned I still remember some of this wave theory. So like light is both a particle and it's a wave, okay? So one is an electric wave that goes one way, and the other is a magnetic wave that goes 90 degrees opposite. So light is a particle. You go outside and you feel the sun. You can actually feel it, it heats you up, right? That's the photons hitting your solar panel is what's actually causing the physics to move the electrons to generate electricity on the solar panel. So it's a particle, but it's a wave in that it has light to it and it helps you see. So it's a particle and a wave. Well, radio waves are the same. They have two different, an electro wave and a magnetic wave. So there's an electronic component and a magnetic component to it. So this is, 2-2 is basic metric units, okay? So if you know metric units like kilometer, kilogram, okay, that's the starting, right? So kilogram is 1,000 grams, right? So in the same thing, hertz is a unit of measurement of time. 1 hertz is 1 cycle of a wave. So I'm going to show you an example here of the wave on 2-3, okay? 2-3 has some waves of going up and down, okay? So, just think of a pool, or even, like take a string or a cable, go like that, and it's waving, right? So if it's waving really quickly, over time is this way, and if you go up and down super fast, over time, it's really small waves, and it's called a high wavelength or high frequency. If you go slowly, the wave is bigger. So wavelength is so let's say this is 0, you go up, past 0, and then down, negative, and then back up. So 1 full cycle from up to down to up, that's 1 cycle, it's 1 hertz. And so how many times in a second does a wave go up and down? That's called a hertz. So electricity, AC for example, I'm getting a little ahead of myself, but AC is alternating current and DC is direct current. In AC, the electrical current goes from positive, back to 0, back down to negative, and then back to 0. So it makes 1 full cycle. And it does that at 60 hertz, which means it does it 60 times in 1 second. So that is a hertz. If it does it 1,000 times in a second, that's 1,000 hertz. And that's known as 1 kilohertz, okay? So kilohertz, back to the metrics, that's why it's useful. So kilohertz, kilogram, kilometer, is 1,000 of a gram, a meter, or a hertz. So that's why you need to know that. You can do the same thing in computers, kilobyte, 1,000 bytes, megabyte, million bytes, gigabyte, what is that? A billion bytes, a terabyte, trillion bytes, I think. So if you take the metric system, 10 to the 1, that's 10 things, or 10 to the 10 squared is 100, 10 to the 3rd power is 1,000. So you have kilo is 1,000, kilo, hecto is 10, like hectare is 10 acres, I think. Deca, like a decapolis is a city of 10 cities, or a decade is 10 years. Deci is going the other direction, 10 to the negative 1, so 1/10. So like a dime comes from that. Centa is 1/100th, so 0.01, or 10 to the negative 2. So for example, cent that takes 100 pennies to make $1, so it's a fraction of a dollar. So centa is 1/100th. Milli is 1/1000th, millimeter, milligram. Micro is 10 to the negative 6. Nano is 10 to the negative 9th. I think nano is 9. Pico is 10 to the negative 12. So they may tell you like, okay, 500 milliwatts is how many watts? So it's 500 is, milli is 1,000. So 500 is half of 1,000, so it's 0.5. So it's a half. So that's a test question, T5B05 on here. And so you just got to know the basics of, okay, 1 kilovolt is how many volts? 1,000. Okay, kilovolt, pretty straightforward. So if you just kind of know some of these, and you can look in the test bank questions here about which of these you might need to know. Pico, milli, kilo, micro, and mega. Those are the ones that look like they're showing up here on the test questions. So 1,000, 110.
Say that again, pico, milli.
Yeah.
What was the other one?
Yeah.
Milliwatts, so milliamps, milliwatts, megahertz, T5B07. So they're kind of listed there on T2-2. So I'm going to go over waves a little bit on 2-3. So I talked about the cycles already. So there is, well, this is a really good, in figure 2.1 here, it shows you the example of a 1 hertz, 1 cycle, 2 cycles, and 3 cycles. So 1 cycle, you can see it goes up and down 1 time over the second, so it's showing you 2 seconds. On 2 frequency, or 2 hertz, you can see it's like twice as many up and down points, so that's 2 hertz. 3 is the same thing, 3 hertz is 3 times as many as the 1. So those are the cycles and the frequencies. So the amplitude is how far up the wave goes, also known as AM broadcast, FM and AM. AM is amplitude, so it modulates based on the height of the wave. So when you transmit voice, it varies the height of the wave of the radio, and then it converts that to speech. So AM modulates the height of the wave. Frequency modulates how fast the radio oscillates here, like 1, 2, and 3 hertz, like I showed you. So FM radio uses the frequency, where AM radio uses the height. Okay, so let's see here. Okay, now I'm going to go 2-4. This is called the radio spectrum. So the full spectrum covers light, microwave, X-ray, visible light, lots of different frequencies. It's called the electromagnetic spectrum. So on 2-3 at the top of the page, it shows you the abbreviations. These abbreviations you do need to know. There's a table on 2-2. So for example, VHF stands for very high frequency. Okay, UHF, ultra high frequency. HF, high frequency. MF, medium frequency. LF, low frequency, and VLF, very low frequency. And then on the right, it tells you the range. So the smaller the number, the slower the frequency oscillates. So VLF, LF, MF, HF, and so on. It goes from left to right. So those are kind of the frequency ranges of the bands. They're called a band. So HF is a band or a range on the frequency. So when people talk about the VHF band or the UHF band, they're talking about these frequencies. So VHF is 30 megahertz to 300 megahertz. UHF goes from 300 megahertz to 3 gigahertz. So we talk about a wireless 2 gigahertz, 2.4 gigahertz wireless network, or a 5 gigahertz wireless network. So 5 gigahertz would be operating on the SHF. Because it goes faster, it can transmit more data. And the 2.4 gigahertz Wi-Fi is going to be operating on the UHF frequency. So you can see it crosses the band depending on which Wi-Fi signal you're putting out. It's a different band. All right, I'm going to go quickly. I might just pause this because I'm going to see if our 8 o'clock net is actually going to run or not. But so 2-5 on figure 2.4, they talk about a spectrum analyzer. So the higher radios that are more expensive, they have what's called a spectrogram, so they can see all these different frequencies at once. So I don't get into that, but this is just kind of illustrating the principle. If you're, say, a general class and you want to say what band is open, where can I listen to people, you'll see these peaks and you're like, all right, the highest peak is where I want to tune in and see if I can hear a conversation. And the lowest peak, I might be able to hear, but it might be faint. So it kind of shows you the spectrum of where to tune in. And I don't think there's any test questions on that, but they just have that as kind of information. All right, so 2-5 and 6. I'm going to go to 2-6. This one is a very simple formula that you have to know to answer 2 or 3 test questions. So you may have heard, Albert Einstein, what mathematical formula do you think of when you're Albert Einstein? E equals mc squared, right? E is the energy, m is the mass, c is the speed of light squared. So if you split an atom, it's the mass of the atom times the speed of light squared equals the amount of energy that's released, say in a nuclear bomb or whatever, okay? So that's the formula for energy that Einstein came up with. Well, the c is the speed of light. So the formula here for frequency of how fast a frequency radio oscillates, this is about in the middle of 2-6. It's got a lambda symbol, which looks like, if you're not familiar with Greek letters, looks like an upside down Y. That's called lambda. So frequency equals c divided by lambda. So the frequency of a radio wave is the speed of light divided by lambda, which is the wavelength. They give you an example here. So the speed of light is 300,000 meters per second, and that's measurement. You can measure the speed of light in feet, but for this purpose, it's meters per second. It's a metric system. So if you had a 300 meters per second, that's the speed of light, and frequency in megahertz, say if you have a 1 hertz, you just multiply that out. So 300 divided by 1 megahertz frequency is a 300 meter wavelength. So if you're solving, they might ask you, what is the wavelength of a 1 megahertz signal? You just take 300 divided by 1 megahertz and you get 300 meters, and that's your answer. So I'm just going to touch on that briefly for the sake of time. We'll come back to that later, and we'll go to the next page. These ones are pretty straightforward. 2-7, there's a basic amateur radio station. It's just a block diagram. That might be a test, and they might point to this little fork-looking thing on the top and say, what is that? Oh, it's an antenna. Okay, so if you know the fork is an antenna, that's all you need to know. All right, so basic amateur radio station block, they have the transmitter on the left, you have a switch, and then you have a receiver, and then you have an antenna with a feed line connecting the antenna. So back in the old days of TV, VHF TV, before cable and everything came out, we used to have a little 300 ohm radio antenna going up to the roof with what's called a Yagi antenna. I didn't know it was called Yagi, I just knew it was a TV antenna, but it's called a Yagi, or horizontal beam. Anyway, we have one of those on our house, and we had a little motor that you could rotate it. So if you're trying to get a station on the north, you turn it north. If you want to tune into another station on a different time, you turn it south and you get a better reception. Well, you do the same thing with ham radios if you really want and you're into it. I don't do that because I don't have the equipment or the time or the interest, but some people do that. But you have this antenna feed, or the cable that connects it. So you have a transmitter that transmits out your voice, and then you have the receiver that receives in through the antenna. So that's your basic diagram. And in the next page on 2-8, the same thing, only with the repeater. Like I was mentioning earlier, you transmit on one frequency and you receive on another. There might be just 2 different radios, and they use the same antenna feed line. Transmits on one on the same antenna and receives on the same antenna. And you have what's called a duplexer to combine. Duplex at meaning 2 combines the 2 radio signals into one antenna. So you don't have to put up 2 antennas, you just put up one. And I'm going to stop there on end of chapter 2, and thanks for watching my video. Now we're going to stop and do question and answer. All right.